along with 10.2. So for the introduction part, it's just about knowing the names of the conics. So while you're studying this, is certain comets and the Earth could be modeled using ellipses. In this chapter, we give geometric definitions for the conics and use the distance formula and the regular rectangular coordinates to find their locations. Historically, in 200 BC, Apollonius was the first to study conics, and today they're still studied because of their many uses. They call them paraboloids of revolution when their parabolas rotated about their axis of symmetry. Those are used for signal collectors, like for satellite dishes with radar and dish TV, as solar energy collectors, as reflectors like telescopes, light projection, and so on. The planets circle the sun in elliptical orbits, and that's also used to reflect signals such as light and sound. The hyperbola helps you determine the location of lightning strikes, and the Greeks used them to study conics, but now we use analytic geometry, which uses both algebra and geometry. Okay, so the word conic comes from cone, which is the geometric figure that can be constructed, and so we need to look at page 635 for the figure with two inverted cones. So in this figure, you can see that, one cone is on top of the other, kind of like an hourglass. And if you cut it sideways, kind of like Fruit Ninja, or however you want to say it, it's straight across, it's a circle, because that's the figure. Now, if it's tilted and it's just the upper one, it's an ellipse. If it goes through like this on the bottom, it's a parabola. And then if it's straight up and down, that's a hyperbola. And so then there's some technical definitions. I really don't want to read through this in the video. You can read through it's basically the description. The one thing that I will mention is it's a circle when it's horizontal, and it's an ellipse when it only goes through one of them. It's called a nap, N-A-P-P-E. It's a parabola when it's parallel to only one and only intersects one, and the hyperbola is when it's both. And so it looks like symmetrical parabolas. So we'll do these a little at a time. There's only 4 questions in this section, so we're going to do them in the notes. It's just like definition type questions. If a plane is perpendicular to the axis and intersects each generator, then it's called a circle. That's right. If it's tilted, so it intersects a generator. Now they're calling a generator the same thing as a cone, basically. But if it intersects a generator but only one, it's an ellipse. It's basically just all your definitions. If it's tilted, so it's parallel to one and only, it's a parabola. And if it intersects both, then it's a hyperbola. Okay, so that was 10.1, which was just an introduction. Now, we're moving on to parabolas. Now, where have you seen these before? You've seen them before if it's y equal x squared. Or y equal negative x squared. Now, you may have seen it before if it's sideways like that, because that's x equal the square root. I'm sorry, y equal the square root of x. But if you have both sides of it, then it's called x equal y squared. So basically you square both sides and that gives you positive and negative values. And if it's the left side, then that's x equal negative y squared. So based on signs, you'll know that if it's positive, it's either going to be up or right. And if it's negative, it's either going to be down or left. And it depends on what's squared as to whether it's, down or left, for example. If it's x squared, down. If it's y squared, left. If it's negative. Okay, so you're going to have certain characteristics in this, and some of these you're going to be able to get on the calculator. The parabola is called like the collection or locus of the points, the same distance d from the fixed point f, which is the focus, and the line d is called the directrix. Now, this is pretty detailed compared to what you've done before. So basically, you're going to have a parabola, like as an example this. Well, the f is going to be some distance inside the parabola, and the directrix is going to be the same distance, but it's a line. The directrix is a line. And so if it's oriented like this, it's going to be y equals some number. And the focus would just be an ordered pair, x, y. And you'd have the same x value as the origin. Well, it's not really an origin, it's the vertex. So this is the v for the vertex. And then you're also going to have an axis of symmetry, which it makes symmetric. Line of symmetry. And it's where it folds in half. Okay, so then you've got some really technical things. The main thing is you do have some formulas, and they're showing you how they got the formulas. And then the bottom line is you're going to get plus and minus 2a, and then the distance is 4a. So let's look at page 638 so you can see what we're talking about. Here's just the first theorem, but on 638, you have this box here, and the easiest ones have the vertex at 0. And so like here, when it's to the right, the focus is to the right. Here where it opens left, the focus is on the left, and so forth. There's the upwards and there's the downwards. Now, you'll notice that the directrix line is a vertical line for these two, and it's a horizontal line for those two. And so there's your formulas. And it's even more complicated formulas when you're not at the origin. So like if you're not at 0, 0, that's when it gets really weird, where you have to add to either h or to k, depending on what you're doing. So like in this problem, you moved over, and so it's the vertex plus a little bit or minus a little bit. And same thing here. Those were the x coordinates. These are the y coordinates plus a little bit or down a little bit. So that's what all these formulas are. You're really just going to want to reference this on right, left, up, down, and reference this. Again, right, left, up, down. This was when it's at HK instead of the 0, 0. So things to remember about the parabolas. First, figure out the direction that it opens based on the information given. So if it's x squared or negative x squared, it's up or down. So try to make a picture. If it's y squared or negative y squared, then it's right or left. Use either characteristics given, the graph or the equation. Now sometimes you have to set that 4a part of the formula equal to -1 or to another number and then work it out. Other books and shapes and curves use C instead of A for the focus. I think in Algebra 2 they might have used C, but in pre-cal, for whatever reason, we use A. The lattice rectum, which you may have read about earlier, determines how wide the parabola opens. So you could have one that's very wide, or you could have one that's skinny. You have to use that for Math Excel for accurate graphs. Remember to do 2a for the distance, and it has the same x coordinate. 4a is the entire distance. So you'll see these as we do the problems. Remember the algebra topics like completing the square using FOIL and combining like terms. The calculator has you solve for x or y instead of the square term. Remember, you can check your work since the answers can't be in decimal form. They have to be in simplified square roots. And then they're talking about some word problems with suspension bridges, a mirror, and so forth. A searchlight and a telescope. So here again are some application pictures that you could see. So there are lots of types of problems. Finding the equation and graphing it and so forth. You can read through those. Now, what you may remember from the last section when we talked is that you could go to equation template and we want parabola, which is number 2, and that's where it shows you your vertex form or your standard form. So I'm just going to do a basic one. I'm going to put 2 in front and then make it at the origin. So if I'm making it the origin, I just keep it at 0, 0. And notice it changed from E1 to F, from F1 to E1. And so there it is. Then you'd go 6 analyze graph, 8 conics, and that's where you can do things like your foci. And I think all you do is click the parabola and it tells me the answer is 0, 1/8. You could also go to Analyze, and do your directrix. And, again, when I move it to the parabola, it's showing me, I need to move it. It's showing me this equation of this line. It's a horizontal dashed line, y = -8. Because if I went up 1/8 for my focus, then I go down 1/8 for my line, my vertex right in the middle. And let's see, what else can we do? The lattice rectum is number 9. And so again, I think you can just move your mouse pointer. And then it showed up. That time it just said a half U. I'm not sure about that. We'll have to do that on a problem. Is there anything else hiding behind? No. Menu, analyze. The axis of symmetry on this one's pretty easy. It's just straight up and down. And it showed you your equation x = 0. Anyway, it just depends on what they need. There's not asymptotes on it. There's not a radius or a center. I guess you could look for the vertex this way. And it popped up as 0, 0. So anyway, there's powerful features on the calculator. So the main thing is use menu, analyze graph, analyze conics. And also there was the equation templates. Use equation templates. So that was 6 and 8. And equation templates was, if you do 3, then 3. Menu, 3 for graph entry, and 3 for equation templates. Okay, so let's get started. The first thing is this question is asking about being symmetric to the x-axis. So if you see a question, it may change it from x-axis to y-axis or whatever. So you're going to want to graph where you are. -2, -3 is down here. And if you're symmetric to the x-axis, that means you're going to move the same distance. And so you go from -3 to +3. So it moves to quadrant 2. Remember, 1, 2, 3, 4. So that's your answer. Also, a little basic one. If it's a minus, remember it goes to the right. And this +3 means up. And then this one, I just wanted you to pick the right equation. If it's opening up, then it's going to be based on x squared. And so they're having you do this one, the 4a, and then this. So notice the vertex is at HK. It's like X and Y. Okay, that's probably a good stopping point for the first video. Hope that helps.